Let's start with the information given in the question. ABCD is a square. Points G, H, and F are tangent points of the circle. The length of the line segment AG is 12 units. Angle ECB is 30 degrees. And we are asked the area of the circle. Now let's begin our solution. First, let's start with connecting the center of the circle with tangent points G and H. Now remember that a line passing through the center is perpendicular to the tangent line at tangent point. So the lines we drew earlier will be perpendicular to the sides of the square. And the length of the yellow lines will be equal to the radius of the circle. From here we can see that line segments DG and DH will also be equal to r units. We know that the side length of the square is 12 plus r units. So line segment HC will be 12 units. Now remember two tangents theorem. Line segments created by two tangent lines intersecting outside a circle are equal in length. In our case, line segment CF will also be 12 units using two tangents theorem. Now let's also connect center of the circle to tangent point F. And let's also connect points H and F. We know that this angle is 60 degrees. So triangle HCF will be an equilateral triangle. And line segment HF will also be 12 units. Now remember Tangent-Chord theorem, which states that an angle created by a chord and a tangent line on a circle is half the measure of the arc. In our case, arc segment HF will be 120 degrees. Therefore, central angle HOF will also be 120 degrees. Now we can apply cosine law on triangle HOF to find the radius of the circle. Cosine law gives us the equation 12 squared equals r squared plus r squared minus 2r squared times cosine 120. From this equation, r can be calculated as 4 times square root of 3. And since we know the radius, we can calculate the area of the circle by pi r squared. So the area of the circle will be 48 pi. This will approximately be equal to 151 units square. And that will be our answer. I'll see you next time.